Hello class, welcome to class. Today we're going to talk about the reverse power rule and using this to integrate some functions. All right, so take a look right here. We have the formula for the reverse power rule. It just says that if we take the integral of x to some exponent n, then this is what we get. We increase that exponent by 1, and then we divide by that new exponent. And then we put this plus c here. And I'll explain that in a little bit in a second in case you already don't know why that plus c needs to be there. Okay, so why is this called the reverse power rule? Well, everything is the opposite of what we did for the power rule with the derivative and in the reverse order. So if you remember, if I took the derivative of x to some exponent, then that became n times x to the n minus 1. So I multiplied by the old exponent and then decreased it by 1. Well, here with the reverse power rule, we increase the exponent by 1 first, and then we divide by the new exponent. So we do the opposite thing in the reverse order. So that's how I remember the reverse power rule. Now, we can check that this formula will work. So remember, this is called the integrand. So here is how you can check your integrals after you've calculated them, at least your indefinite integrals like this. You can take the derivative of what you get, and if it becomes the integrand, if you get that back, then you know you did it correct. So for example, let's take the derivative of the right-hand side of this formula. So we multiply by n plus 1, and then decrease the exponent by 1, and the derivative of c becomes 0. And so n plus 1 cancels, and we just get x to the n, which was our integrand, which means that we did it correctly. And so that's kind of why we always have to add a plus c at the end of all these definite integrals or indefinite integrals, is because we don't know, like this is the derivative of something, and we don't know if that something had a constant because it went to 0 when we took its derivative, okay? So that's why we always have to put the plus c. It just is some arbitrary constant. Sometimes you will be able to solve for c if they give you some more information, but if not, then we just put plus c. Okay? So that's the reverse power rule. Now we're going to look at 3 examples. We're going to start with the easy and then go medium and hard. So let's take a look at the easy one first. Okay, so let's start with this easy one. For this easy one, what we can do is we can actually split up each of these integrals, kind of like what we did for derivatives, and do each one separately, like so. So I'm writing it like this. Don't forget to write your dx with each one. That's important so you don't get points taken off. Okay, and now I can evaluate each one separate. So first thing, notice this 3. A property of integrals you probably already learned is that that 3 can come outside of the integral. So this one just becomes 3 times the integral of x to the 4th dx, okay? And that becomes 3 times, okay, we're going to do the reverse power rule. So x to the 4th, we increase it by 1. So it becomes x to the 5th. And then we divide by that new exponent, which is 5. So that becomes 3 times x to the 5th over 5. Now this guy over here becomes x to the 4th over 4. And this 2 over here, remember that this 2 is the derivative of something. And so we're like undoing that. So what is 2 the derivative of? Well, it must be 2x. All right? So the integral of a constant just becomes that constant times x, or whatever variable you're integrating with respect to. And don't forget the plus c there at the end. Okay, so this is our answer, but we can check this pretty easily. If we take the derivative of this, remember that we should get the integrand back. So let's do it. So the derivative of the first guy, so now I'm just taking the derivative here of all of this, just to check. This becomes 15x to the 4th over 5 plus 4x cubed over 4 plus 2 plus 0. So this becomes 3x to the 4th plus x cubed plus 2. Is that the integrand? It is. It's what we started with. So we know that our answer right here, this is our final answer, we know that that is correct. Okay? Now, for the next two, I'm not going to check them. I'm going to leave that for you guys to check, but we are going to solve them. So let's go on to the medium question now. Okay, for the medium question, you can see that we have a lot of fractions and negative exponents, and we have a radical in there. So the first thing that we want to do is we want to make sure that everything in here is written with exponents so that we can do the reverse power rule, okay? Just like what we did with derivatives, right? If we had something like this and we had to take the derivative of it, you would rewrite it so that it had exponents. So that's what I'm going to do, and I'm also going to split them up too. So I'm going to rewrite this as the integral of x to the 1/2 dx plus the integral of x to the -3 dx. And now this -6 right here, I'm going to take that out. So we're going to do minus 6 times the integral of this guy becomes x to the 4/3 dx. So now that I've rewritten it, I can do the integral of each one of these individually. So the first one, this becomes x to the 1/2 plus 1, which is 3/2, divided by 3/2. Okay. Now, I want to make a point here that dividing by a fraction is the same as multiplying by that thing's reciprocal. All right. So I'm just going to go ahead and rewrite this as 2x to the 3/2 divided by 3. Okay? So when I'm doing this, I usually skip this step right here and go straight to this. So I multiply by the reciprocal of the exponent instead of just dividing by it if it's a fraction. Okay, now for the next one, x to the -3. A lot of people make this mistake. They'll make it x to the -4, but remember, we're increasing -3 by 1. So this becomes x to the -2 divided by -2. So I'm going to write that down here as -1/2x squared, because I'm just go ahead and rewriting this as a positive exponent down there. Okay? So that's that one. And now we have -6 times whatever this becomes. So we increase it by 1. So we're adding 3/3 to 4/3. So that becomes x to the 7/3. And then remember, I'm going to multiply by the reciprocal because that's the same as dividing by the fraction. So I'm going to multiply by 3/7. So this becomes 3x to the 7/3 divided by 7. And then plus c. Now let's rewrite it, clean it up a little bit. So this becomes 2x to the 3/2 over 3 minus 1/2x squared minus 18x to the 7/3 over 7 plus c. And like I said, I'm going to leave it to you guys as an extra practice to take the derivative of that and make sure that you get the integrand back. Okay? All right. Now let's look at our hard question. Okay, so now let's take a look at this hard one. Okay, so as you guys can see, there's a lot going on here, but it's not much different from the last one. We just have this little extra x squared. So let's rewrite this, and as I'm going along, I'm going to change all the radicals to exponents, and I'm going to divide everything by x squared. So this becomes x to the 1/2 divided by x squared plus, now here, I'm just going to make this x to the 1/3 times x to the -2 all over x squared. And we'll simplify this later by just moving this down here. But for now, let's leave it like that. And then minus 2x over x squared, okay, dx. So I rewrote it. And let's simplify it one more time and split everything up. Okay, now at this point, what I'm going to do is, remember, if you have the same base, then we subtract the exponents. So I'm going to do 1/2 minus 2. So this becomes x to the 1/2 minus 2. Okay, so that becomes -3/2 and plus dx plus the integral Now here, this becomes, I'm going to kind of do this one off to the side. This becomes x to the 1/3 divided by x to the 4th after I move that x to the -2 to the bottom because it's a negative exponent. And that becomes x to the 1/3 minus 12/3. Which is x to the -11/3. Okay? So that's what that one becomes, x to the -11/3 dx. And then the last one here, you see this -2, so I'm going to take that out. That becomes -2 times the integral of those cancel, and that gives me 1/x dx. All right, and now it just becomes like the medium and the easy one. We just do the reverse power rule here. So for this guy, this becomes x. We increase it by 1, so we're adding 2/2, so that becomes x to the -1/2, and then times -2/1, multiplied by the reciprocal of the fraction. Plus, now we're going to increase this by 1, so we're adding 3, so that becomes x to the -8/3 times the reciprocal, which is -3/8. And now this one, the reason that I included this in our question here is because a lot of people might want to at first try to go ahead and use the reverse power rule with x to the -1, but you cannot do this, okay? This actually has a special rule with it, and this becomes -2 times the integral of 1/x is the natural log of the absolute value of x. And that may look like it came out of nowhere, but remember that 1/x is the derivative of something, right? And by doing the antiderivative, the integral, by integrating that, we're figuring out what that is the derivative of. Well, just remember your derivative formulas, right? The derivative of natural log x is 1/x. So it makes sense that the integral of 1/x is natural log x. Okay, so now let's clean this up. This becomes -2 over the square root of x. That negative exponent, just move it to the bottom and make it a radical again. Minus 3 over 8 cube root x to the 8 minus 2 natural log absolute value of x plus c. And that is our final answer. Okay guys, so that was the reverse power rule. Thank you so much for watching. If you have another topic that you want me to cover, please leave it in the comments below. Otherwise, have a great day.